Good morning. For the next screencast, I'll be showing how to take a quadratic equation in standard form, rewrite it in vertex form, and using that, create some interesting points that we can help graph this function with. All right. Well, we first start with what is vertex form. It's y equals a parentheses x minus h squared plus k. To write an equation in vertex form, I need the values for a, h, and k. Well, the a in standard form will be the same a in vertex form, so since a is -1 here, I know that a must be -1 in vertex form. To find h, the formula is h equals -b over 2a, so in this case it'll be -3 over 2 times -1, so that's just 3 over 2. To find the value of k, I take the value I've just found for h and plug that answer back in for x in the standard form equation. By doing so, I get negative of 3 halves squared plus 3 times 3 halves plus 2, which would equal -9/4 plus 9 halves plus 2. So that I can add all these fractions together, let's get a common denominator of 4. So that would become a 4, that would become an 18. This would become a 4, and this would become an 8. Adding the numerators together, I get the value of k to finally be -9 plus 18 is +9, plus 8 more is +17 over 4. So now I know that h's value is 3 over 2. K's value is 17 over 4. Okay? So in vertex form, erasing this work now, I can see that my equation would be y equals -1 times x minus 3 halves squared plus 17/4. Now to create some points on this graph, I'm going to make an XY table just to organize my work. If I want to graph the parabola using 3 points, I always put my vertex, which is 3 halves, 17/4, in the middle, and I'm going to pick a point to the left and a point to the right of the vertex that are mirror points of each other. All right, since this x value is 1.5 or 3 halves, I'm going to pick 1, which is to the left of 3 halves, and 2, which is to the right of 3 halves. I now will plug in 1 into either the vertex form equation or the standard form equation to create my y value. I think it'll be easier to use the standard form equation since I don't have fractions there. I would get y equals negative of 1 squared plus 3 times 1 plus 2. So when I do that, I get -1 plus 3 plus 2 is 4. So when x is 1, y is 4. Since 1, 4 and 2, blank are mirror points of each other, since that value is 4, the y value for the second point must also be 4. Graphing this out, I would get my y-intercepts, or my vertex is 1.5, 4 1/4, so 1.5, 4 1/4 would be like right here. My next points would be 1, 4, so right here. My other point is 2, 4, which is right here. If I'm interested in other points, such as the y-intercept, I could plug 0 in for x in either equation. Again, I think the standard form equation would be easier, so I get y equals negative of 0 squared plus 3 times 0 plus 2, which just ends up being 2. So my y-intercept is 0, 2. All right, so I know that my parabola would now go through that point. And if I wanted another point, I could go over to the right to 3, 2. And let's do one more set of points. Let's find the x-intercepts. To find the x-intercepts from this equation, I'm actually going to use the vertex form. Since there's only a single x in this problem, I can just plug 0 in for y and solve for x using the opposite of the order of operations. I would subtract the 17/4 across, divide by the -1, give me positive 17/4. Get rid of the square root sign by square rooting both sides. That gives me positive and negative square root of 17 over the square root of 4 is 2. And that equals x minus 3/2. And so lastly, solving for x by adding the 3/2 to the other side, I get x equals 3/2 plus or minus the square root of 17 over 2. So my x-intercepts would be 3/2 plus or minus the square root of 17 over 2, comma, 0. All right, I could graph those out. I could estimate where those out, but I'm just going to go ahead and connect my points now with my parabola. Smooth curve there. All right, and that's what my parabola looks like. The last interesting ideas that we need to think about when we talk about parabolas are the domain and the range. Since a parabola goes forever to the left and to the right, the domain with this would be all real numbers. Or we could say from negative infinity to positive infinity. The range talks about how high up to how low down to how high up the graph goes. Since this is facing downward, I know that the range of this guy will be y has to be less than or equal to my maximum value, which in this case is basically 4.5 or 4 1/4, which is 17/4. In interval notation, that would be from negative infinity to 17/4, including 17/4. All right, that's how we change a quadratic from standard form to vertex form, and how we graph that and look for the interesting bits and pieces of it. Talk to you later.